Hello, I'm George Maylim, the Managing Editor of Vanilla Plus, and welcome to today's webinar. Thank you very much for joining us today, and we hope you and your families are well. The topic today is using data science to capture and increase visibility of M2M roaming traffic. It's easy to forget that roaming never stands still. Mobile operators are continually faced with new challenges that affect their ability to either grow their roaming business, scale their networks to meet roaming demand, or maintain the transparency and control needed to efficiently monetize their network assets. To handle more routine issues such as spikes in demand, surges of traffic from previously unaddressed markets, and other shifting patterns of traffic, operators need to use the data they have better to enable them to plan more effectively and react rapidly to the changing landscape. I'm delighted to welcome today's speakers from BICS, Talia Goldstein, the Head of Global Roaming Business, and Damien Rose, the Product Manager for Mobile Signaling and Roaming Solutions at the carrier. They will explain how to derive the most value from every connection with inbound M2M and IoT detection through utilizing data science and machine learning to identify the devices already on your network and to analyze how they behave and then take the best steps to extract value. I should point out that both Damien and Talia will be staying on to take questions from the audience after their presentations. To participate, simply enter your question in the panel on screen and I will put it to them. Before I hand over to Damien, we're going to run the first of today's polls to gauge everyone's understanding of the issues. I'm going to read out some questions and possible answers, and do feel free to vote. This will happen live, and then I'll hand over to Damien to look at the findings. The question is, what are your sources of international M2M roaming traffic? And the possible options are roaming partners only, roaming partners and other third parties, device manufacturers and integrators. The fourth possibility is enterprises, and the final possibility is mobile virtual network enablers. And the votes are still coming in, but it's clear that the main source seems to be device manufacturers and integrators. Damien Rose, was that roughly what you were expecting to see?
Just a quick check here. Can you hear me clearly?
Yes, I can hear you clearly, Damien.
Okay, perfect. To be honest, I would have expected more the roaming partners only as the, that's the answer. That's me. I am surprised to see that a lot of people are directly dealing with device manufacturers and integrators, but it does make sense. Okay. I would have expected to see the top response being roaming partners, or at least roaming partners with some other third party.
Yeah, I thought that would be the case too, but that's interesting. Anyway, might shed some light on the composition of today's audience. Great. Well, I'll hand over to you, Damien. The floor is yours.
Okay. Well, good afternoon, everyone. Thanks a lot for joining the webinar. Hopefully, you'll all find it informative, and thanks a lot for taking the time in these confinement periods for us all. Okay. Sorry, there was a delay in the slide becoming available. So the topic of today's webinar is using data science to capture and increase visibility for your M2M and roaming traffic. And the whole idea here is to discuss how we can better leverage information that we have, apply the correct data science techniques to leverage the insights this data could be hiding for you today in order to apply that to business questions that would hopefully help you better monetize and get the most value out of every connection in your network. Now, Talia and I are from BICS. BICS is a global carrier, one of the leading global carriers actually in SSM signaling, LT signaling, and data transport. And so we're in the business of not just connecting entities and operators and enterprises globally, but to help them figure out how to actually extract value and create value actually for their customers and the other people that they support and serve. We've been around for the last 20 years, focusing a lot on innovation. In the last 5 to 10 years, actually, we've had a very keen focus on using data science to actually make better use of the data that we have as a global carrier across multiple protocols and technologies to help our customers understand a bit more what's happening in industry. I'm not going to go too much into the business slide details here. If everybody's okay, then we move into the actual topic. Now, BIX has the perspective, and I hope it is being shared more and more by not just mobile operators, but any business that exists today, that we're all in the software business. And this has been something shared by a number of people. Most recently, the current CEO of Microsoft echoed this concept in one of his speeches last year in 2019. And the whole idea is whether or not you're a mobile operator, you're a social media guru, whatever your business are in today's various markets, the software that you have is a key component of your competitive advantage. And having the right software can actually make the difference between making or breaking your business case. If we take the screenshot that I provided here, regardless of which aspect of your business you're looking at, so whether it be retail billing, wholesale billing, if you're a mobile operator, the value-added services that you deliver to customers, your customer churn or your campaign management, whatever elements of your business that you currently focus on to see how you can stretch your competitive advantage, in some ways comes back home to the quality and the utility of the software that you apply in your business. We're pretty much all in the software business, and making the choice on the right or the wrong software has its implications. So what are the possible choices here? You can focus on probably partnering with the players who provide you with the best-in-class software to support your business needs. You can also choose to invest in developing in-house what you need from a software perspective and take it forward. But at the end of the day, we all somehow need to acknowledge and understand that we are really competing based on the software that we have deployed in our various business components. Okay. Now, the slide we have in front of you here, it's tailored towards mobile operators, in the sense that for a very long time, mobile operators have looked at their networks as just a means of providing connectivity and telephony services to some end user. And what I'm challenging the people listening to me today is to reimagine the mobile network as a platform, meaning thinking what platforms do. Platforms provide a series of services to some end user or a group of end users, and over time learn what the concrete and specific needs of these user communities are, and create value for these different user communities, and that is how they actually drive their business. If you think about your Facebook, your WhatsApp, your Salesforce, whatever platform, Amazon, whatever platform you were to look at, the focus is, yes, we want to connect people in some way, shape, or form, create a user community, but the value creation part of it is how you grow not just your business, but the competitive advantage over time. Now, if you look at the mobile network, you have a platform providing coverage, normally seamlessly, or at least that is the demand, seamless coverage. A platform that needs to provide coverage but performance coverage, meaning you need to have the right data speeds, the right quality of service, the right accessibility, the right uptime over time. You need to provide a secure platform. So whatever device or person connecting to your mobile network is expecting a certain degree of security. Same thing for availability, reliability, and priority. The point is, when you take all the different elements of the mobile network that users value, you see that what you really have is a platform that can possibly be better monetized by making the most out of each of these individual elements, and seeing how best you can create value from them. So catering to the specific requirements of users, and in this case, different types of users. And this is actually a good segue into the split we're going to have further in the conversation, where you have your human users, your traditional users of the mobile network, especially in the roaming domain. Traditionally, we're all people. But today you have a different user group who are not people, they're machines, and they have very different needs for coverage, performance, security, availability, reliability, etc. You also look at the strategic alliances that are important to you and also to this new user group. The alliances or the partnerships you had before for traditional mobile telephony or traditional mobile roaming may not be the ones that are going to be needed to compete effectively in for the user group, for example, where we're talking about machines in roaming. And finally, you do need to still have the level of transparency that you've always relied upon in your legacy mobile business. And again, bringing it back to roaming, you've always tried to maintain a level of control between your roamer leaving your network and going to a roaming partner's network, so a visited network, and also providing your partner's network with the transparency of what's happening to their roamer in your network. So creating the transparency needed and maintaining control, whether it be for humans or machines, in this new platformification, I guess you could say, of the mobile network is also critical. Now, the question is, okay, you think of a roaming or a mobile network as a platform. Where is the value in this concept? And it comes down to the business model. A lot of mobile operators have been struggling over years to find the right way to grow their business using legacy business models. You know, you're going to compete on price, or you're going to compete on the type of mobile phones you make available. What exactly are you using to differentiate yourself across different segments? And it so happens that today we have segments that cross the line between humans and machines. And so you can reimagine again your business model. So we need to focus a lot more on not just how much value there is to be captured, you know, how much money is projected to be in the market in the next 5 to 10 years, and not so much either on how will I necessarily create value. You know, will I invest in this network technology? Will I partner only with this particular group? But actually start focusing on how will I capture that value? What will I be doing to sufficiently differentiate myself while creating value for some user who no longer needs to be a person, but can also be a machine? Trying to get to my next slide. Sorry. I'm having a little bit of a lag here with the slides. So let me just see if I can correct that. Here we go. So now what you should be seeing on your screen is the outcome of a survey we did sometime last year. Actually, I'm not sure who on this webinar may have listened to a previous webinar that I did last year around the possibilities of applying data science to detect machines. Now, the question at that time, what most operators had, was essentially how is exactly, when we're talking about monetization of M2M and IoT, do I get the transparency needed to build the trust with the various players? Today, I don't know which of my roamers is a human. I don't know which of my roamers is a machine, so I can't properly monitor their behavior and learn, for example, the use characteristics. How different is a connected device in a, let's say, a connected car from a human? What is the difference between a silently roaming machine versus a silently roaming human? These questions were not possible to be answered. And so it was very difficult to imagine what the business cases and what the monetization approaches could have been. Now, taking a step back, we've actually taken the information we receive from our customers and our partners and all the different players who have given us insights about what the key challenges are for them for M2M and IoT monetization. And we've gone ahead and actually invested ourselves in this ability. And this is actually what you're seeing on the right side of the slide. We've used data science to effectively allow us to learn which of the roamers that we see globally are machines or demonstrating machine type communication versus which ones are demonstrating human type communication, so that we can observe what these different types of roamers are doing on a day-to-day basis. This allows us to actually not just detect, but quantify and observe this behavior and apply that obviously to the different business questions that may pop up and arise, not just for BICS, but also BICS's customers and partners. Now, for you as the mobile operator or the end user, or sorry, the person who's trying to leverage M2M and IoT, it is important to understand that there's a huge value potential in applying data science. This is only one use case that we see here, the detection, but you can apply it, for example, to the quality of experience. Today, for example, a lot of the information we have is skewed by the fact that machines and humans are mixed into one KPI computation bubble, for example. Is success rate only for my people in roaming, or is it only for my machines roaming? These are some questions that maybe today we don't even ask ourselves clearly. So the idea here is to simply address the question of how can I, one, segment my roamers effectively using data science into those who belong to a particular category. And we're not talking here about demographics. We're talking about a fundamental difference in terms of behavior and communication types of machines and humans. I apologize, I'm a little bit winded. The summer air isn't dealing very well with me. Okay, so coming back to this, hello, George? Hello, George?
Hi, Damien.
On my side, I'm having a little bit of a lag, sorry, with the screen. Is
the slides are fine. We can see them clearly. We're on slide 9 at the moment. Is that what you expect?
Okay. Yes. Okay.
I think the problems are mainly it's probably caused by lots of people being at home during the lockdown periods that we're having across most of Europe. So there might be some lag at your end, but the slides are presenting well for the audience.
Okay. Thank you very much for that. Okay, so I'm going to continue assuming that the slide that I want is on screen. So as I just mentioned to you before, the underlying question is, one, can I determine whether or not a connection is going to be from me, a human or a machine? And two, can I determine the lifetime value of my connections? This is actually one of the fundamental problems that operators have had when trying to come up with a clear answer as to how to properly, one, monetize machines in roaming, and two, build the business cases necessary to make this a success for my business. Now, obviously, there are various ways that you can tackle this approach, as in, the question of how do I separate my humans from machine. It doesn't have to be data science. Obviously, I'm an advocate for the application of data science, specifically machine learning, but this is not the only way to attempt to do it. The problem is the other available options are not complete, and in many cases, incomplete and inaccurate. Now, one of the popular methods, for example, is to do deep data mining of the usage records for our roamers to see if this somehow tells a story as to whether or not they're a normal human roamer, or they may be this demonstrating the behavior or the expected behavior of machines using business rules. When we talk about usage records, I'm talking about specifically TAP, so transferred, the transferred accounting for roamers at the wholesale level. We're also talking about the near real-time transfer of usage records to near trade information, and also in many cases combining TAP and NRTRDE, so the near trade, with the device information itself. So normally every roamer device has a specific key, the IMEI, that allows you to understand if it's an Apple device or if it's a Samsung Galaxy, whatever it might be. Normally very specific. Once these two things are available, usage and device data, then you can do certain business rule driven analysis to say if it's potentially a human who's actually using this device, or if it's a machine that's just connected to the network in some way, shape, or form. In our research, we obviously looked at all possible angles, and we found that this type of approach, where you just use business rules and essentially the lowest hanging fruit, which is usage information and device information, isn't sufficient to properly classify any roamer as a human or machine and scale across the billions, or the millions, I should say, of roamers you're going to see in a day, month, or a year. And the reason is actually quite simple. For you to be able to use usage information or device information to make a classification decision, you have to have this information in the first place. And roughly 40% of roamers, normally the silent roamers, the ones who don't do anything in a network while roaming, do not generate the information in the network. They don't send SMS, they don't make voice calls, they don't use data, so they don't generate usage. And normally when they're silent, they're pretty much just camping on a 2G signaling network, so SS7 network. So the problem is that in an SS7 network, the parameter, for example, the device information is not a mandatory parameter to be passed. So because it's not mandatory, normally it's not passed anyways. So the device information is missing, there's no usage, there's no way to classify. So if you just take this type of approach, you're going to be missing roughly 40% of all the roamers, which means even if you somehow manage to classify some roamers, you're going to be missing a big chunk of the roamers that you can't actually see. using this approach, which means you need to somehow find a lower level of measurement that is going to be common to every single roamer. And this has to be the signaling activity that roamers generate in the network. Now, it doesn't matter if you're human or if you're a machine or if you're using a Galaxy S3 or a Huawei, whatever, you will have to connect to a network, and in connecting to the network, you're going to be generating signaling traffic. You will have to pass subscription information within the signaling traffic that will tell the network, for example, if you are for SMS, voice, data, if you are, what are the maximum speeds you're allowed to get in terms of the quality of service that you're going to be given. For voice, although voice is activated, you'll also have to mention to the network, am I allowed to, for example, have third-party calls? Do I have the ability to actually redirect calls to my voicemail? A lot of information about the technical parameters and setup of a subscription are going to be available at this very low level of detail, which is the signaling and data transport traffic layer. Okay, so if we forget the limitations of usage data and device data, and we now start looking at the low level traffic data that every single device has to generate, we actually find a lot of potential, because we know now we can probably have 100% coverage, but it also comes with the complexity of the 5 Vs. And this is where we enter the realm of big data and data science. We're going to have a lot of volume. So each individual roamer can generate thousands of records daily. And we're going to now multiply these thousands of records across hundreds of millions of roamers. So we have huge volumes to deal with at this layer. We're also talking about the velocity, so the rate at which we have to capture, process, and store, and also maybe even report this information becomes very minute. So you need to be able to do this in a very performant and efficient way. So volume and velocity already add a level of complexity that makes you start looking towards data science as a possible alternative. When we throw in the mix the variety from the different protocols that we'll have to deal with, and obviously the need for the data to be reliable, in order for you to be able to trust what it's saying, then it is obvious that if you really want to be able to tackle this specific issue of detection of machines in roaming, to understand the difference between machines and roaming versus humans, and also extrapolate insights needed to drive a business case for M2M roaming, you need to look at data science at some point, okay? That said, data science is not ubiquitous in the mobile space. There's a lot of players in IT where this is a very comfortable domain. But if we're to be real, in telecommunications, data science is somewhat nascent. There are applications today. People are looking at things like churn prediction, location-based services driven by machine learning algorithms. Data science is definitely finding its space in telecommunications today, but it is not yet the norm. It's definitely not yet something that everybody's comfortable with. But the good news is it's not necessarily comfortable either. It's not necessarily difficult to inject this into the day-to-day operations either. So without going into the details of what you would need to, kickstart data science as a mobile operator, let's just look at what we're going to be trying to find using data science, and specifically machine learning. By first of all looking at what is machine learning. Machine learning is essentially the attempt to make a computer system behave like a human being in terms of coming to a decision by looking at past or historical data and applying it to current data to make a classification decision. In short, in machine learning, we're trying to feed historical data to a computer system and have that computer system come to a similar decision that a human would with the same information. Now, there are two ways to get a machine learning model or a system that is using machine learning to do this. You have a supervised method and you have an unsupervised method. In the supervised method, you're essentially providing your machine learning model or your computer system with things called features and labels. In other words, you're providing information with a clear way to tell what it is. If we were to imagine, for example, let's say a mobile phone, and we know the specific weight of a mobile phone that is an Apple let's say an Apple 8 device, we know the weight of this phone, we know the dimensions of this phone, we know the color that this phone comes in. If we were to provide the weight, the dimension, and the color to a supervised learning model, then this model over time will be able to use these features, weight, dimension, color, to correctly guess if a phone that is currently unknown is an Apple 8 or not. So you provide information that has features, in this case it's weight, dimensions, and color, to apply a label, which could be Apple 8 or Galaxy S3, whatever the feature then specifies, to make a classification decision. So in other words, the supervised machine learning model is specifically tailored to handle the classification problem. How do I give a yes or no answer to an unknown group of entities? And actually, this is important because we will need to apply classification. We will need to be able to look at a huge number of roaming subscribers and essentially ask our machine learning model to say if it's a human or a machine classification problem. Now, the next arm of machine learning is the unsupervised method. Now, here we don't know the specific features and we don't have a label to apply to the data. All we're concerned about is to identify similarities and differences. It's a clustering problem. If you imagine having a huge range of stats about, for example, different players. I came across a really good example once about cricket players. I'm not sure if you guys are familiar with cricket, but cricket is a game, it's a bat and ball game, similar to baseball. And in this game, you have fielders, you have batsmen, and you have bowlers. Now, if you're just giving statistics about for each player in a given game, the total number of wickets taken and the total number of scores run, you are able to quickly see that there are going to be at least two clusters of players. You have the players that have a lot of wickets and maybe low runs, and you have another cluster of players who have a lot of runs and maybe no wickets. You'll definitely have a few mixes, in the middle somewhere, but you're going to have two primary clusters: high wickets, low runs, high runs, low wickets. There is no label. All you know is that these are the commonalities. Someone like myself, for example, would then have to tell my model that ones with high wickets and low runs are going to be my are going to be my bowlers. Okay, so they're going to be the ones who are trying to actually pitch the ball at someone who's going to try to bat it away. Now, the ones who have high runs and low wickets are probably going to be my batsmen. Now, these are labels that I'm now giving the clusters that the model was able to identify. But before I gave these labels, the cluster had no concept of batsmen and wickets. So in unsupervised learning, it's really a clustering problem to identify similarities or differences that are meaningful, and then having some third party or external system provide the labels necessary. Now, once you have these labels, then in the future, it's easy for the machine learning model to identify batsmen and bowlers. Okay. Now, I went through that just now, and it actually was a little bit more challenging than initially thought to kind of break down in a very simple way what machine learning is all about. Hopefully, I did a good job of doing that. But at the end of the day, all you really want is to train a computer system to make a decision using historical data. Okay, and there's two ways to approach it. In one method, you're able to actually clearly provide enough information for the machine learning model to say yes or no if something is, something falls into a particular category. The other method is where you just want the machine learning model to tell you where the distinction is in a huge group in terms of clustering them, and then you provide meaningful information in terms of labels for that data. Now, if we come back to the application of data science specifically to the machine detection model, if you recall 2 slides ago, we pointed out that using business rules based on usage and device information were insufficient. And the natural conclusion is we need something more common, something that every device will do regardless of its type. We come to the traffic. Now, in today's roaming, you have 3 main categories of roaming traffic falling into the domain of SS7 signaling and all the different protocols and messages within that domain. Diameter signaling, specifically S6A, that handles the mobility part of 4G roaming. And you also have the GTP protocol for the data transport. You have the control plane, yes, but you also have the user plane. But from a mobility perspective, the thing that the device has to do, we'll focus on the control plane. Now, when you take all the different protocols and message types belonging to these three domains that every single roamer does, you'll see that even here you have a difference in distribution. Depending on which network, depending on which access technologies are available, is it a 2G, 3G only access network? Does the network provide a 4G coverage as well? Is it a CDMA network, for example? Depending on the specific technological complexity of that network, then for a given group of IMSs or roamers in this case, the combination of available data varies. In some cases, you'll see that we'll have a good mix, like to the far right. Most of these roamers in network 3, one to the far right, produce almost equal volumes of SS7 diameter and GTP traffic. Okay, you do have some where they only produce GTPC, so the control plane traffic for data transport. You have some that are only generating the control plane traffic for 4G roaming, so LTE 6S6A. You also have obviously different combinations. But the interesting part is a significant portion are still only generating SS7 traffic. And as I explained to you before, SS7 is probably the least informative of all the protocols when it comes to how to classify a machine, because it misses the device information, which is actually present in diameter and present in GTPC. And normally, if you're doing only SS7, at best you may be an SMS user. As in, if you're using SMS, then okay, you're an active in terms of usage, but you're only using SMS, you're not using very much data. You could also be using voice as well. But it's the least informative. In the middle graph, we can see that for some operators, the problem actually is expounded by the fact that the vast majority of the images in a given network will only then generate purely SS7 traffic. So in other words, the number of roamers where I have such limited information for to make a classification decision is actually huge. I don't have the ability to actually rely on, again, device information, which is available normally over here. And this is common across the hundreds of networks that we have looked at, that there's a huge percentage, actually it averages around 40 to 45% of roamers generate only SS7 traffic. So even when we look at the thing that roamers have to do, the underlying mobility traffic, there's still this challenge of how do I make a classification on traffic where I am not guaranteed to see useful information. The good thing is this is where these two elements of data science come into play. First of all, what we need to understand is what elements of this seemingly useless SS7 traffic, okay, because we now need to find the driver. Here we know that it's fairly easy to make a classification if we have at least more than one protocols, SS7 and LTE, or SS7 and GTPC, but clearly we have a problem when it's SS7 only. So let's solve that problem, and once that is solved, everything should fall in place. So the trick here is we need to find out what are the common characteristics of SS7 signaling traffics that apply explicitly to machines versus what apply explicitly to humans. And if we can manage to find enough of those and train a model to find them in an automated way, then we can then apply supervised machine learning, where we can actually then start putting roamers into humans and machines. So yes, it's complicated, it's very tedious, but it's actually doable. And here we're talking about features like the number of spam messages that a particular roamer received. We're talking about the number of unique SMSCs that a particular roamer contacts, either in terminating SMS or originating SMS. There's a lot of very fine, peculiar things that happen that actually are unique to humans and unique to machines. And that allows you to start building the picture of what at a signaling level is a human or machine. Now, once you have these features, okay, so this is the detection of what specific things at a very low level I can use to distinguish behavior. I now need to understand which features belong to the humans and which features belong to the machines. Because here, all we know is that there are distinctive elements in SS7 LTR data that is different from one group to another. We don't know which group they belong to. Okay? So the next step we need is to actually apply these distinctive features to different groups, so humans or machines. Now, This becomes a little bit complex because it depends on what information you have today. Because again, a machine learning model relies on historical data to make a classification on new data. Now, if you imagine, for example, having information about chairs and mugs and let's say televisions, okay? The data you have may describe these three categories in a particular way. I may know, for example, that chairs have a particular shape and form, how many legs they have, and the general shape. I may know that televisions come in maybe multiple shapes and form as well. Some are digital, some are analog, some are square, some are rectangle. And I may know, for example, that coffee mugs or mugs in general, again, can either look like this one from maybe a Starbucks or this one from your local bar. The point is, I do have information about what televisions, chairs, and mugs look like. The problem is when you try to apply what you know about these groups to a target domain. Why? They won't necessarily look the same. So for example, to a trained eye like yours and mine, if we cross this decision boundary and go up to the target domain, it's obvious to us that these are chairs and these are mugs. But to a machine learning model, they look very different. Okay, here the chair has wheels, for example, whereas the information it had about chairs before did not include wheels. Additionally, this fancy one has like a star on the back of it. This one does not. And in terms of the mugs, again, it's a little bit different. There's additional information in the target domain that can confuse your machine learning model. And so what we need to do now is to take the information in terms of the features that we learned in the previous step here, where we applied or unsupervised learning to find out which features broadly are different between these different groups, and start applying them to a target domain and taking feedback from the target domain to reinforce or improve the information we have about the distinguishing features. So for example, we take this approach called transfer learning domain adaptation, where we will use information we have learned so far about our source domain, so the shapes, the forms, in the case of humans and machines, all the different features about humans in terms of the average data usage per day, the average number of services that are configured at registration, the average number of VLRs that they register to, a wide range of features about humans and similar features about machines. And we now try to apply them to a group that we don't know to be humans or machines as yet. And the trick here is to be able to learn from this new target domain what additional features could be further used to better distinguish humans and machines and feed it back into our decision tree. So here what we're doing is we're following two paths. One, we're using information we have, applying it to a domain that we know to make a classification. But just before we actually decide in our target domain whether or not the target item belongs to one of the known groups, we want to see, are there additional features that exist in the target domain that does not exist in our source domain? And if they are, we need to pump it back in using a back loop into our classifier, and that will be used as a future step for a more refined application. In short, all you're doing over time here is allowing the machine learning model to self-learn. It's continuously applying information it has already learned from history to a new set of roamers. It's making its classification, but each time it classifies a roamer as either human or a machine, it's also learning new information that it didn't know before that can further refine it. So over time, it becomes more and more accurate, more and more precise, and you have a self-learning, self-governing machine learning model that is reliable enough to allow you to actually tell if a roamer is human or machine. Now, the data science is fun. This was not meant to be a data science lecture, so I've actually tried not to get lost in that discussion. The really important thing is, okay, what can you then do with information? Now, again, assuming you have a reliable method of properly identifying humans versus machines in your roaming, the first thing you want to understand is their behavior. And then you want to understand what is their value to you. In other words, how do you derive the value of each connection over time? Let's take into account behavior first. Behavior can be many things. It can be the type of network activity they generate, so signaling or data activity. It can be their mobility. Are they moving around or are they static? But from a business perspective, the first thing maybe you want to understand is the type of usage. So know that you have the ability to segment your roamer base into two new categories. You can see the behavior and usage profiles of humans, separate and apart from behavior and usage profile of machines, and better understand the relative contribution they have to your bottom line. Now, I've applied this to the current roaming scenario, where roaming has been changing over the last couple of months due to the challenges we're having today with COVID-19. And I started by tracking, first of all, the general number of unique roamers in Asia and Europe for a given operator in each region, and then adding on top of that layers of information to make it a little bit more interesting. Because the cool thing with data science is it allows you to tell different and more interesting stories about the data. It's the same data. Now, if you think about my core data here is I have a way to tell unique roamers, and I have a count of these roamers, but I don't know if they're humans or machines initially. But as soon as I am able to actually split this, I can see, for example, that machines, although they're still in their nascent development stages, the promise of M2M has not yet been fully realized. But as you can see in this graph, they are already significantly contributing to this specific operator's bottom line in terms of both usage, which I have shown the split of. The majority of the usage is actually an SMS, but there's also significant data. But in terms of the total number of unique machines, and we're talking about this blue line here, as the number of unique roamers has been declining, almost 30% of this total number of unique roamers has remained machines. So while people were beginning to go back home and stopping their travels, for example, there were machines that were there and that are going to remain there, either permanently roaming or within devices that are camping in the network, vending machines, whatever the point is. The roaming usage that obviously brings the value to these visited networks was declining, but not so much for the machines who stayed steady. So it became a more and more significant piece of the operator's overall roaming revenues. So a significant contributor here. We applied the same analysis to a European operator. The information obviously is a little bit different, and this will always be the case, okay? As a mobile operator, you have to understand that you operate in different geographies, and you also have access to different regions. In this case, for example, it was an operator in mainland Europe, and as a result, there's a lot of cross-border activity. There's delivery trucks from Amazon, etc. So the behavior is different. If we follow the blue line again, we can see that actually here, machine roaming accounts for an even more significant piece of this person's continued roaming revenues during the quarantine period. And it follows the weekly trend. You can see clearly the weekends versus the middle of the week. And this was actually linked very heavily to the movement of shipping across Europe. All the people who are now doing online shopping, there's a lot of Amazon trucks moving, a lot of different containers and all that stuff moving across borders for this specific operator. And you can see that the machines continue to bring a significant portion of roaming revenues over time. And in this case, okay, it was mostly SMS. And it's a question of whether or not the current business model of this operator allows them to properly leverage this. But it's obvious to see that there's a very interesting story to be told once you have the transparency that data science can afford you to have, okay? Now, I've gone through a lot of topics, I know. Just know 1 hour is really a short period of time to dive into some of these things. Hopefully, I haven't rushed through anything too quickly. I'm trying to be mindful of the time. But at this point, I think it'd be a good time to go back over to George and Talia, just to see if they have any thoughts on what's been said so far.
Yeah, sure, great. Thank you very much, Damien. I believe that Talia's now got some slides to talk through as well. So I'll hand over to you, Talia, and then we can pick up a bit later on.
Thank you, George. Thank you. I promise it's going to be short, but basically I want to take over and share with you the helicopter view of what was just discussed before. So how does the ecosystem works today? So you see in this slide. So indeed, the vast majority of roaming traffic is traditional roaming still. However, up to last year in 2019, M2M represented globally 90% of total data traffic. But since COVID-19, this has jumped to 25%. And according to different scenarios, it will keep this trend for the next 4 years. So all this roaming traffic, M2M and traditional roaming, is transiting through many roaming agreements between what we call an HPMN, which is the home mobile network where subscribers, human or machines, are originating from, and then the VPMN, which is the visited mobile network where these subscribers, humans and machines, are roaming. So if you take a look and put yourself from the visited network point of view, it has on average from 50 to 600 roaming agreements where international M2M transit. So in most cases, this VPMN, this mobile operator, has no visibility on M2M traffic, nor always commercial conditions dedicated to that segment. So while the pricing does not differ whether it's M2M or traditional roaming, network usage can vary a lot and therefore impact the cost. So until recently, most mobile operators had opted for two options regarding M2M traffic in a roaming scenario. The first one is leave the valves open with low visibility. Everything gets in. The second one, a bit more extreme, is implementing strict restriction on permanent roaming for M2M traffic. Now, before, when M2M volumes were low, impact was manageable. And now that M2M data is significantly growing and that customer behavior needs are evolving, we see the market evolving into another direction. So again, this is the current ecosystem. Most cases, I've noted down that some of the participants are already working in a different way. But this is, on my next slide, what we say the future ecosystem, existing for some of you already, but the one we believe into. So this future ecosystem, it's the foundation for transparency and therefore enable operators to manage this M2M traffic while supporting enterprises' requirement. So remember, the first system here is very much relevant. It's the one I just discussed before. But for that, you would need to add on top of it the M2M detection software Damien was referring to, allowing operators to have visibility and be able to manage these roaming agreements commercially, both for machine-to-machine and traditional roaming. Now, operators will be then able to manage commercial aspects, but also network design implication. So how do I manage my network capacity knowing that 40% of my roaming traffic is actually M2M? So on top of that first system, which is the traditional one, where we added the M2M detection software, on top of that system, living side by side, what we encourage is mobile operators to connect to MVNEs, what we call MVNEs or integrators, which are collecting M2M traffic from enterprises only. So what does this option bring? So this option shortens the distance between the enterprises, international connectivity, which are enabled by mobile operators. So in that last model, the second one, you find really an optimal combination of a solution where each player is basically focusing on its core business. And so this is like standing as it is with at least amount of intermediaries. Again, both options implemented as such enable a maximum of option to mobile operators to manage M2M traffic from different sources and with all required transparency. So today, you know, and especially after the COVID, during the COVID, most business will be looking how to support its customers, employees, and today patient in a complete different way. And M2M is a great part of that solution. So we believe that this future ecosystem that I just presented is setting foundation to respond to that demand in the most sustainable, transparent way for all players and for the long term. So this is my contribution to what Damien has explained. So I just brought a bit on the helicopter view, just to show where we believe the ecosystem will go.
That's great. Thank you, Talia. I think we're going to have the second of today's polls now, just to see what we've learned and perhaps consolidate some of the audience perceptions. So it's the same as last time. I'm going to ask the question, and there are 5 potential answers to choose from. The question is, what would be your primary business driver for identifying M2M roaming? And the possible responses are to understand what is already in my network to assess the business case further, to identify roaming partners to approach for strategic partnerships, to understand the contribution M2M roaming is already providing to my bottom line. The fourth response is to monitor the development of M2M roaming in my network. And finally, to understand the behavior and usage profiles of different device types in my network. And I'll just give a few minutes to settle down. But it's looking pretty clear that the fifth response to the question, what would be your primary business driver for identifying M2M roaming, is going to be to understand the behavior and usage profiles of different device types in my network. Damien, I think you've got a statement to conclude with, but what's your view on the outcome of the final poll?
This is in line with my expectation. Actually, there are a number of... Sorry, are you hearing me clearly?
Yes, I am hearing you clearly.
Okay, sorry. There are a number of answers here that I would have been perfectly happy seeing to come out on top. The fact that anyone who's trying to actually get the most out of M2M and IoT in roaming would want to understand the behavior and usage profiles comes out on top is actually in line with the expectation. The gist of what I tried to explain earlier was this is the driving force behind the detection in the first place. You need to be able to, one, distinguish how these machines behave from a regular roamer, understand what this behavior profile might have both in terms of whatever business case you have driving this M2M business, but also your network, the capacity, its ability to actually respond to the needs of these different roaming devices. So this makes perfect sense to me. I would have, however, expected a little bit more responses to have been in the understanding the contribution of M2M roaming already in the bottom line. Yeah. And I think this leads up a bit into my next slide. It's already there. A lot of mobile operators are already benefiting from the presence of machines and roaming in their network. And so understanding what actually this translates to into dollars and cents, I think would have been a little bit higher on the responses. But this makes sense to me as well.
Okay, great. Thank you, Damien. So I'll just hand over to you for you to conclude, and then we'll open the floor to questions after that.
Okay, perfect. Well, hopefully we were able to provide not only the insights in terms of what the data itself can do and how best to approach it. I apologize if there's anything that was not clear. Hopefully we can clarify it now in the question and answers, but it should be obvious, I think, that for the best outcome as it returns to the monetization and the growing of the M2M and IoT roaming, international roaming business, 2 things are necessary. The right amount of effort needs to be placed into the software that supports our business and operations to ensure that we have the transparency, the control, and also the visibility needed to understand what this means both to our network and also to our businesses. And then once we have that perspective in terms of the volumes we're talking about, the types of devices, the different usage profile that each device has, which is an indication of the type of use cases that enterprises are delivering in our various networks. Once we have that perspective in place, we can then start working, obviously, on the business cases to see, okay, how do I actually attract more of these businesses and grow it over time in a strategic way, and identify the partners globally that can help me actually to not only capture the traffic that I'm hoping to grow over time, but to, again, work with me to introduce the transparency and control needed for trust. One of the things that I think has stagnated the rapid growth of M2M and IoT roaming, and also the business benefits behind that, is the lack of trust due to lack of transparency and the perceived lack of control. And the whole idea of focusing on what data science can do for you is to actually inject back this transparency and inject back this control by extracting the information that is already in the data flowing through your networks. So that is my summary here. Science, the software, and the right business strategy and partners, I think, is the only way to remain competitively distinguished going forward as a mobile operator for M2M in roaming.
Excellent. Thank you very much, Damien. Now we'll move on to the Q&A. We've only got a few minutes, so we'll have to rattle through it as quickly as we can. First question that we've got is, what is the degree of accuracy your detection model provides, and in places like Africa with low burst data from human users, is this likely to bypass detection of your model with false positives or otherwise? I guess that's one for you, Damien. Sorry for coming straight to you with a question after your presentation.
No problem. It's actually a really good question. Thank you for asking. For our specific model that we have at BICS, we have an average accuracy of 95% in terms of correctly classifying a roamer as human or machine in near real time. Accuracy, however, is not the only important metric. We also need to talk about confidence. In other words, we can be accurate, but how confident is our machine learning model that its classification was correct? You can, is it a really good guess, or does it know? So in our case, we have high accuracy, that's approximately 95% on average with just SS7 signaling traffic. If we actually have also diameter traffic and GTP traffic for the subscriber, we have actually around 98 to 99% accuracy. But in all cases, we also have high confidence. Our model knows that it's a human or machine. And I always use the analogy of flipping a coin. Accuracy is guessing the outcome of the coin flip. So if you guess the outcome of a coin flip 100 times, if you get it right 95 times out of 100, your accuracy is 95%. But each time you had a 50% chance of getting it right, so your confidence is only 50%. So we measure both accuracy and confidence, and we have on average with just SS7 traffic 95% accuracy, and in each case above 50% confidence. Now, in terms of the African region, because we do not rely on usage data, it doesn't affect our ability to classify whether the usage is bursty or if it's consistent or not, because we're not looking at usage. We're looking at the underlying signaling transactions that have to happen anyways, the network authentication negotiation transactions, the network registration, and the subscriber subscription update information, and the content of the subscriber subscription data, the number of unique SMS, for example, that is being sent and received, if any, the specific teleservices that are being negotiated, and the QoS parameters of each service. So it's very low-level details that, for humans, are very important to the roaming experience. But machines and humans have two very different needs when it comes to actually roaming on a mobile network. So we're actually focusing on those low-level distinctions between the two. So usage is not really a factor, and so it doesn't affect our ability to classify. So no, it doesn't create a loophole.
Okay, that sets up the next question really well, Damien. The question's coming. It says, what are the examples of possible discriminative features for humans and machines in signaling activity?
Well, actually, I kind of just went through a couple of them.
I felt that might have been the case. So is that all? I mean, is there any other way to discriminate between humans and machines?
In our particular case, for example, we have found something along the lines of 150 different discriminating features. Now, I mean, again, this ranges from the type of teleservices being negotiated, the types of spam detection. So, for example, is there spam being sent to or from these devices? The number of unique VLRs I mentioned to you before as well, but also the mobility and also the roamer velocity. On average, how many borders does this IMSI cross? What is the general proximity of this IMSI to another one when we talk about location? Like there's 150 something different features that we compute, but obviously when you're doing your own approach, you will decide which features to compute on, and it can be significantly different from ours. The important thing to keep in mind, however, is that not all features are going to be relevant for all device types. So, for example, maybe a subset of my 150 features will be useful for connected cars. A different subset will be useful for vending machines. A different subset will be useful for scooters that do move and that you expect to be mobile. So it varies depending on the use case, the device type, and the actual behavior in the network. But we do have a wide range of features that we have to compute and see which ones are meaningful for the classification.
Okay, great. Thank you very much. I'm afraid we're out of time now, so all that's left is to say many thanks to our speakers, Damien Rose and Talia Goldstein from BICS, for your great presentations. Thanks also to our audience for sparing the time to attend. We look forward to welcoming you to another Vanilla Plus webinar soon. Enjoy the rest of your day, and goodbye from me.
Thank you. Bye-bye.
Thank you.